Hello there once again, and welcome back to our Chem 151 video series. In this video, we'll investigate acid-base reactions. The description of this reaction is if HCl reacts with Na3PO4, what is the acid and what is the base, what are the products, and what is the balanced equation. Let's first start with part A and how to identify an acid and base. For the purposes of Chem 151, you can think of an acid as a compound that begins with H and is connected to something negative. There are many other acids out there, but this is good enough for Chem 151. The only exception to this rule you'll have to worry about right now is that also the formula NH4 positive, or ammonium, is also considered an acid. If we look to the two compounds given in the question, we can see one of them starts with H, and that's the HCl. That HCl will be our acid. For the purposes of Chem 151, you won't need to know that many bases. There are a lot of them out there, but the ones you'll need to know for this course are any that start with a group 1A or 2A metal and are connected to a 5A or 6A nonmetal. However, instead of a 5A or 6A nonmetal, you could also be connected to a polyatomic ion. We can see here that Na3PO4 consists of a 1A metal, that is sodium, and PO4, which is a polyatomic ion. There are some polyatomic ions that are excluded from this, but we'll cover that in another video. For now, we can think of Na3PO4 as our base. Now, to predict the products, we will break the acid and the base into pieces. The acid pieces consist of H and Cl. We'll also remember to write the charges on the H and the Cl. Hydrogen is in group 1A and will have a charge of positive 1. Chlorine is in group 7A and will have a charge of negative 1. We'll also break the base into pieces. We'll have sodium. We'll temporarily ignore the fact that there are 3 of them and just write that sodium is also in group 1A and will have a charge of plus 1. PO4 is a polyatomic ion, and this polyatomic ion is phosphate. Phosphate has a charge of 3 negative. Now what we'll do is combine the H plus from the acid, that's the positive piece, with the negative piece that came from the base, that's PO4 3 negative. We'll write down that we're going to combine those pieces down at the bottom. And now we'll think about the charges. The charge on the positive piece is 1 positive, and the charge on the negative piece is 3 negative. Therefore, if we combine these right now, we will not have a neutral compound. We're going to have to multiply the H plus by 3 to give us 3 positives. This will neutralize the 3 negatives. When we combine these together, we will end up with H3PO4. We'll repeat this process now with the sodium and the chlorine. Here we can see that sodium and chlorine have equal and opposite charges, therefore you can combine them immediately, and our other product will be NaCl. Therefore, our products from this reaction are H3PO4 and NaCl. Now we write our reactants on the left and our products on the right. We place the arrow between them, and now we'll try to balance the equation. Let's make a note of our hydrogen, chlorine, sodium, and phosphate pieces. On the left, we can see 1 hydrogen, 1 chlorine, 3 sodium, and 1 phosphate piece, bearing in mind that this 4 is part of the phosphate piece. Therefore, we don't say 4 on the left, we only say that there is 1 piece that is PO4. On the right, we can see 3 hydrogen, 1 phosphate piece, 1 sodium, and 1 chlorine. Therefore, our hydrogen and our sodium are out of balance. Let's begin with the hydrogen. On the left, we'll need 3 hydrogen, and we cannot modify the formula for HCl. Instead, we're going to place a 3 in front of the HCl. This multiplies the hydrogen by 3 and also multiplies the chlorine by 3. 1 times 3 gives us 3 hydrogens and the same 3 for chlorine. This means now the hydrogens match and you have 3 for both, the left and the right. However, now the chlorine is out of balance. So since we now have 3 chlorine on the left, we must get 3 chlorine on the right. The chlorine is located in the NaCl on the right, and therefore we'll need 3 of those to give us 3 chlorines. So this will multiply our chlorine by 3, but since sodium is part of the compound, it will also get multiplied by 3. So on the right side of the equation, we have 1 times 3 chlorine giving us 3, and 1 times 3 sodium giving us 3. Since we have 3 chlorine on the right, that matches the 3 chlorine on the left, and now the chlorine is in balance. The same with sodium. We have 3 sodium on the left, and now 3 sodium on the right, and the sodium is in balance. The phosphate pieces are 1 on the left, 1 on the right, and they're okay too. That means this reaction is now balanced. And so not only have we predicted the products of an acid-base reaction, we've balanced the equation as well. Thank you for watching. We'll see you again soon.